scheduling algorithms. That is, this is the structure of the magnetic disk. That is physical structure of the magnetic disk. There are several platters that we can see in the diagram. Then cylinder, and we can see several tracks on the platters, and we can see the several sectors on that particular tracks. Okay, so already we have seen this lot physical structure. Now we are going to discuss about the disk scheduling algorithm. So consider here, yes. Consider the speed of the disk is measured as two parts. First one is the transfer rate. This is the rate at which the data moves from the disk to the computer. And the random access time, it is the sum of the seek time and the rotational latency. So seek time is the time taken by arm to move the required track, and rotational latency is defined as the time taken by the arm to reach the required sector in the track. All these points already we have discussed. Okay, so even though the disk is arranged as sector and track physically, the data is logically arranged and addressed as an array of blocks of fixed size. The size of a block can be 512 or 1025 bytes, 24 bytes. Each logical block is mapped with the sector on the disk sequentially. In this way, each sector in the disk will have a logical address. Now we can see the disk scheduling algorithms. So first, on a typical multi-programming system, there will usually be multiple disk access requests at any point of time. Means disk, uh, any data we require on the disk, and we have to access that particular data from that disk space. So it may be the requirement. So those requests must be scheduled to achieve good efficiency. So with a good efficiency, we should access these requests, or we should fulfill these requests. Disk scheduling is similar to process scheduling. Some of the disk scheduling algorithms are described below. So first disk scheduling algorithm is first come first serve. This algorithm performs requests in the same order asked by the system. Let us take an example when where the queue has the following requests with cylinder numbers as follows. That is, first one is 98, 183, 37, 122, then 14, 120, 124, then 65 and 67. Assume the head is initially at cylinder 56. The head moves in the given order in the queue. That is, yes, the name, as the name suggests, first come first serve. Whatever request uh, sequence is there in the queue, it will be followed, and the scheduling algorithm will be get processed according to that. So first of all, the after 56 cylinder, it will move to the 98, then 183, then 37, then 122, and then 14, then again 124, then 65. That also we can see in the diagram. below. So these blue lines can we can see as they are processing according to the sequence. So the second type of scheduling algorithm is shortest seek time first. Whichever is the seek, shortest seek time, then that cylinder will be get processed first. Means data from that particular cylinder we can access first. So uh, here the position which is closest to the current head position is chosen first. Means whichever position is nearest one that we are going to choose. Consider the previous example where disk Q looks like. So we will take the previous example. In that the current head means head is initially at the cylinder 56. So which one is the nearest from the sequence of Q is uh, the 65. So the 65 will be get processed first, and then the next nearest one is 67, then 37, and then 14, and then after 14 98 is here. After 98 122, then 124, and then 183 will be get processed. Now this is the shortest seek time. Okay, so SSTF. And next type of algorithm is scan algorithm. This algorithm is also called as elevator algorithm because of its behavior. Means it is going to proceed or process uh, first from the left, and then after getting covered all the requests from the left, it is going to cover the requests from the another side. Okay, that is right side. So here first the head moves in a direction, say backward, and covers all the requests in the path. Then it moves in the position opposite direction and covers the remaining requests in the path. The behavior is similar to that of an elevator. That's why let us take the previous example. Okay, we will consider the same example here. Assume the head is initially at cylinder 56. The head moves in backward direction and axis is 37 and 14. Then it goes in the opposite direction and axis the cylinders as they come in path. So we can see in the diagram. First of all, 56, the head of the um, head will be at 56 cylinder, then it will come out the 37, then go for the 14, and then go for 65 and 67, then 98, then 122, then 124, then 183, and then 199. So this will be the sequence, and that's it for all.